Okay, so in this second part of the video, we are going to have an example. So we learn more, right, if we understand its applications. So that's what I am as a type of learner. So ito siya. Now, independent t-test is also known as a two-sample t-test or independent samples t-test. It is a statistical used or test used to compare the means of two unrelated groups. So they should be very unrelated. It determines if there is a statistically significant difference between the average scores of two distinct groups. In applied data science, Kanisha is commonly used to evaluate differences in outcomes between two distinct populations or experimental conditions. So for example, okay, natay problem statement. We are going to compare two microcontrollers kinsa sa ilaha ang may, maybe faster ang loop executioner time. So Arduino Uno ba or ESP32. So in embedded system design, execution speed is a critical factor that influences system responsiveness and real-time performance. So this study aims to evaluate whether there is a statistical significant difference. So mean to say, non-directional siya, no? In execution time between two commonly used microcontrollers, Arduino Uno ba or ESP32. Both devices were tasked to run a simple loop function repeatedly, and the execution time in milliseconds was recorded across 30 trials per microcontroller. So this data right here that I have uploaded to you guys is anong tawag dito? Is parang generated lang, no? So, but we can also do that in real life. We can test both, no, if we have time. So, for a one-tailed hypothesis, which one has a higher or greater execution time than the other? So we can say Arduino Uno does not have a greater execution time than ESP32, or Arduino Uno has a higher greater execution or has a higher execution time. No, and we can phrase it the way you want it. Alternative naman is Arduino Uno has a greater execution time than ESP32. So mas mataas daw yung execution time. Whereas a two-tailed naman, we just say there's no significant differences between its execution time of the two microcontrollers. And there is a significant difference for alternative analysis, alternative hypothesis rather. So let me just share my screen. Entire screen. So let me just open JASP. I would like you to download the software tool JASP screen. Sige. So what we should do is that, okay, I will slowly do it so we can like open, because I have already downloaded JASP. So we can actually download this kanisha. Microcontroller execution time ang atong gamiton dere. So I have already downloaded the CSV file. Take note that the file should be in a CSV format, no, not in a XCS or Excel file. So we can open the downloads, and for me, I actually did download it in my downloads folder. So I think this is it. Yes. Mm-hmm. Yeah. So actually, we can name it as 0 or 1 in data science because the machine cannot understand the words like Arduino Uno and ESP32, but that would be in AI na. But for data science, we can actually also do that in our later topics, no? 0 or 1. So if you learn about descriptives, so we have the variable, which is the microcontroller here, 60, and sorry, split natin. This is the execution time, and then microcontroller. So both Arduino Uno and ESP32 are valid. So si Arduino Uno, in data science, we can actually like infer already, no, that Arduino Uno has a faster execution time than ESP32 because of the mean that we currently have right now. But the standard deviation is that it deviates a lot, that 4.5. It's actually a huge deviation. So, for the inference, for like saying our opinion using the data right here, or this is actually just based on what we see, right? In the data, not an opinion. So we can actually put the mode, the median, right? The skewness, kurtosis, everything, no? Whatever data that we are required to have. So we can also see the basic plots like the QQ. Yes, as you can see, this is for Arduino Uno, its execution time, and this is for ESP32. And you see that ESP32 is quite normally distributed, right, than what we see in Arduino Uno. There are what we call outliers, mga saag, no? And that makes sense because we see that in ESP32, it has a lower standard deviation. Okay, so we can actually also see the box plot of both. Where is it? Yun, yan siya. So we see that the Arduino Uno has a higher execution time than ESP32, no? Kita na to sa box plot pa lang. Scatter plots, I think we can also use this. So just for our interpretation, para na gyud sa ato ang t-test. So kana lang siya, describe lang sa nato. But descriptive. Based on the graphs, based on the numbers that we see, we can interpret them. Okay? What are other important matters here? I think that's it. Most commonly, box plots, QQ plot, these plots are very important for data science. So since these are two different groups, we use the independent sample t-test. Okay, kani siya pisliton lang. I hope that is seen. Okay, so dapat ako siyang i-full. Yan. So the dependent variable here is a grouping variable, and this is the execution time. Yeah, as you can see, both. Tanaw na to ang p-value. No, sorry. Balik ta pa siguro. So you can see that this is a group variable, right? Grouping variable. So we put that there. Yan. Because microcontrollers are grouping variables, and then this is the execution time of both. Yan. So there is a p-value of 8.949 and a p-value of 0.001. And earlier, we talked about that if the p-value or alpha value is less than 0.05, then that means to say that we sa man siya, delete screen, slideshow. That we reject null hypothesis. So if we reject null hypothesis, we need to say that there is a significant difference. Significant difference, sorry, difference. Mali spelling. Between the execution time, that is for two-tailed. And Arduino Uno does have a greater execution time than ESP32. Okay, so we use, since our, one-tailed man tano, ang giingon nato was greater daw si Arduino Uno kaysa kay ESP32. So group 1 is greater than group 2. Yan siya. So you see the alternative specifies that group Arduino is greater than ESP32. Meaning to say that really Arduino Uno has a greater execution time than ESP32. If we change it naman to a one-tailed na group 1 is less than group 2, meaning to say that Arduino Uno is less than group 2, so the p-value is changed because makes sense because going back, dili man mas dako si ESP32 kaysa kay Arduino Uno. And that is also based on our plots, di ba? So the p-value is 1. So ato adjong accept si null ana or i-reject si null kay dili man tama, di ba? Di ba p-value ana siya dinhi Arduino Uno group A is less than group B. Tapos using one-tailed test, so the p-value is 1 and 1 of course is greater than 0.05. So that is we failed to reject the null hypothesis. Okay, I hope that's clear. So, okay, let us once again using the independent samples t-test. Group 1 is greater than group 2 because we have a one-tailed alternative hypothesis of Arduino Uno greater than ESP32. So meaning to say that we reject pag sa ganito ang yung ganina pag less than 0.05 we reject the null hypothesis. So if reject the null hypothesis, we of course we accept this alternative hypothesis. So Arduino Uno really has a greater execution time. Pero nag-change siya because nangyari siya 1. So we accept the alternative if that happens. No? Kung ato ang i-change, ESP32 is greater than or has a greater execution time than Arduino Uno, pero nag-1 ang imong p-value, Arduino Uno is AU na lang. So meaning to say that we failed to reject the null hypothesis because Arduino Uno is greater than dapat. No? So this is very important, kanisya. Okay, pag naman non-directional, so non-directional siya, since p-value is 0.001, then there is really a significant difference. We reject null hypothesis, we accept this. There is a significant difference between the execution time and between Arduino Uno and ESP32. Okay, so can you please do this as well? And I'd like you to submit it in BBL. Next is part 3, the pair t-test. So this is this was the actual presentation of that lab report.